Today, we're going to pull back the curtain on one of the most incredible, unseen journeys that happens every single day. It all starts with something super simple, the flush. But what happens next? Well, that's where things get really fascinating. So let's dive in. I mean, seriously, have you ever thought about it? You flush the toilet and poof, it's gone. But where exactly is gone? Well, it turns out gone is the starting line for a massive process that keeps our cities from getting disgusting, protects our rivers, and honestly, protects our health. And that journey's first stop is a place called the headworks. The easiest way to think about the headworks is to picture it as the bouncer at a massive nightclub, which is the treatment plant. Now, the bouncer's job isn't to get the party started, right? No, their job is to stand at the door and make sure nothing gets in that's going to wreck the place. It's all about protection. It's crowd control for chaos. And trust me, that bouncer has its work cut out for it. Because what's trying to get in is, well, it's a mess. Raw wastewater isn't just water. It's this wild, chaotic soup of everything we flush and send down the drain, plus sand, gravel, and all sorts of junk. And it all comes flooding in at totally unpredictable times. The Headworks is built to tame this chaos. Okay, so the first challenge is all about physics. Before you can even think about cleaning the water, you just have to get a handle on it. That means, first, getting it up to where you can work with it, and second, knowing just how much of it you're dealing with. See, most of our sewer systems are powered by good old-fashioned gravity. The pipes all flow downhill, which means by the time all that wastewater gets to the treatment plant, it's usually way deep underground. So job number one is just lifting all of it, the water, the trash, you name it, back up to the surface so gravity can take over and pull it through the rest of the plant. So how on earth do you pump a liquid that's full of who knows what? Well, you use this brilliantly simple piece of ancient tech, the Archimedes screw. These things are amazing. They're just massive corkscrews that can lift the water and all the solids mixed in it without ever really clogging. It's a total workhorse. It just turns and lifts whatever comes its way. So once the water's been lifted, you gotta know how much is coming through. And you've got two main options here. You could use a fancy, high-tech magnetic flow meter, or you could use a partial flume. And you know what? The flume usually wins. It's basically just a specially shaped concrete channel that's almost impossible to clog. And the best part? You can literally check if it's working right with a tape measure. In this kind of messy, tough environment, simple and bulletproof is almost always the way to go. All right, we've lifted the flow, we've measured it. What's next? Well, think of it like you're about to cook pasta. The very next step is to grab a giant colander because it's time to get all the big chunky stuff out. And by big stuff, I mean all the things that people flush that they absolutely, positively should not be flushing. We're talking rags, plastic wrappers, and, oh yeah, those so-called flushable wipes, which are the absolute worst. Basically, if it's big enough to jam up a pump or clog a pipe later on, the goal is to yank it out of the water right here, right now. And a really common way to do that is with something called a catenary screen. It's such a simple and smart machine. The water flows through what looks like a big metal comb, and all the junk gets caught on the bars. Then the whole screen moves like a conveyor belt, lifting the garbage up and out of the water, where a rake scrapes it all off into a dumpster. Simple, mechanical, and it just works. And this brings us to what is basically the golden rule for everyone who works at one of these plants. It's a simple phrase with huge importance. Once you take it out, do not put it back in. Now, that sounds totally obvious, right? But there's a really, really good reason for this rule. I mean, you might be wondering, why not just use a giant industrial grinder and shred everything into tiny little pieces? Great question. But here's the problem. When you shred things like rags and plastics, they don't just dissolve. They actually start to weave themselves back together as they float down the pipes, forming these long, disgusting, super strong ropes that are even worse than the original trash. They can wrap around pumps and cause way bigger problems. So you get it out and you keep it out. So the big garbage is gone, but now we have to deal with a different kind of problem. The small, heavy, and seriously destructive stuff. It is time to get the grit out. So what is grit? Well, it's pretty much what it sounds like. It's the sand, the gravel, coffee grounds, eggshells, broken glass. Basically anything that's small, heavy, and abrasive. If you let this stuff get into the rest of the plant, it's like pumping liquid sandpaper through everything. It just grinds away and destroys super expensive pumps and pipes. So getting it out is non-negotiable. And how they get it out is actually really clever. It's all about physics. You can use an aerated grit chamber where you bubble air through the water to create a gentle, rolling spiral. The current is just strong enough to keep the lighter organic stuff floating, but the heavy grit drops right to the bottom. Or you can use a vortex chamber, which is basically a man-made whirlpool that slings the heavy grit to the center of the tank where it can be collected. So cool. And notice a theme here? The goal, again, isn't really to clean the water. Not yet. The goal is just to sort it. We're using physics to separate the heavy, inorganic stuff we want to get rid of from the lighter, organic stuff that the rest of the plant is actually built to treat. Okay, so we've lifted it, measured it, screened it, and degritted it. We're almost done at the headworks, but there's one last huge problem to solve. The plant is still totally at the mercy of our collective daily routines. Think about it. In the middle of the night, there's barely a trickle of water coming into the plant. But then, in the morning, when everybody wakes up and starts showering, flushing, and making coffee, bam, a massive tidal wave hits the plant. It's like going from an empty country road to a 5-lane traffic jam in an instant. Trying to treat water that way is just crazy inefficient. So, what's the solution? It's called flow equalization, and it's basically just a giant holding tank. During that morning rush hour, the tank fills up, kind of like a buffer. Then, later in the day, when things quiet down, the plant slowly feeds that stored water back into the system. It smooths out the peaks and fills in the valleys. And why is that a huge deal? Because now the rest of the treatment plant can run at a steady, constant, super efficient pace all day long. Everything works better. And get this, you can even build the downstream parts of the plant smaller and cheaper because they don't have to be big enough to handle that once-a-day tidal wave. It's just smarter all around. Okay, so let's recap. We have lifted, screened, degritted, and smoothed out the flow. We've done a ton of work here, so the water's got to be clean by now, right? Not even close. And if you take away just one thing from all this, let it be this. The entire headworks, everything we have just talked about, has almost nothing to do with actually cleaning the water. It's all about mechanical prep work. It's about getting all the physical junk out of the way to protect the more delicate and, frankly, more important processes that are about to happen. So, yeah, the headworks has done its job perfectly. The big physical threats are gone, and the flow is nice and steady. But the real challenge, the actual cleaning part, hasn't even started yet. So how do you get rid of all the dissolved pollution? The stuff you can't even see? Well, that is a whole other story.